Okay, the first outcome. Do you remember what this is called with these straight brackets? Absolute value. So that absolute value, what's the big idea? If you absolute a positive number, what would happen to it? It would stay. If you absoluted 0, what's the absolute of 0? Stays. And then what happens when you absolute a negative value? It would change to positive. Okay? Okay, solving absolute equations. What would be the first step? I'm going to want to isolate that absolute. Okay, so we're going to do this first. Add 7. Add the 7 first. Divide by 2. Okay, now, here's what we're going to think. Does it make sense that inside those brackets, I could have technically have had an 8 or a negative 8? Would that work? Does that make sense? So at this point, I'm actually going to drop the bracket part, and I'm going to say the inside could have been 8, or the inside could be negative 8. So now I don't have brackets on this anymore because I'm saying the inside part could be 8 or the inside part could be negative 8. So if you are not putting brackets where you should be putting brackets and dropping brackets where you should be dropping them, you will get a deduction in communication. Okay, and then it's just the further out solving here. So we're going to add 1.
Do you have an extra paper budget?
Always somebody. Always someone.
Forget it or something?
I think I was working on it.
Just because you want $1,000.
Yeah, it doesn't mean you're a hot shot.
Yeah, come on.
Alright, thank you.
If you're getting a fraction, just leave it. Just leave it as a fraction. Okay, number 2 here, I'm going to minus 10. Minus 10 to get that isolation part. And now what? No solution. Okay, what do we know about absolutes? Once you absolute something, can you ever get negative? No. Remember, absolutes are kind of thinking about distance. So could this distance ever be negative 8? No. Okay, and right, if I absolute 8, I get 8. If I absolute negative 8, I get 8. I'm never, ever, ever going to get the negative. Okay, graphing. So graphing, there's our big ideas at the top. If it's positive, it stays. If it's 0, it stays. If it's negative, it has to change. So what pieces of this graph will I... Actually, you know what? I should also write the symbols. Here I say graph the absolute value. On your test, I would say graph the absolute value like this. If this is the graph of f of x, I want you to graph the absolute value of f of x. So on your test, you have to be able to recognize the question. Okay, so I'm going to look at what would stay. So the positives are 0 heights. So this will stay. I need to overlap it. This will stay. Okay, this is going to change. This is going to change. Okay, this has an arrow, so mine has an arrow. That doesn't, so mine doesn't. So when you are done an absolute value graph, there should be nothing below there when you're done. Okay? That makes sense? Because absolutes always have to be 0 or more. Okay, this next one. Well, first of all, you have to know something about this function. And I expect you to know how to just graph this function. What does the x squared function make as a shape? Parabola. There's a negative in front of that x squared, so what kind of thing? It would look like that, right? And then what's the 5 all about then? A y-intercept. So there's a y-intercept of 5. And, oh, I should be doing this lightly because this isn't my graph yet, but what should I do now? What kind of pattern? What kind of moves? 1 over, 1, down, 2 over, 4 down, 3 over, 9 down. Okay, I'm doing this lightly because this isn't even my graph yet. Because once we're done that piece, we're going to say which parts of this graph do I keep, which parts do I change. Okay, so this will get to stay. We're going to have to change these 2 pieces at the bottom though. Okay, I'm actually going to take this coordinate. My coordinate ended up getting to be 3, -4. Is that the same as your graph? 3, -4? Where would I specifically move that coordinate? 3, +4. And then I'm just going to graph the rest with it. So I did do a specific point, and then the rest followed. Okay, in grade 12, you're going to do a lot of graphing like that when you're moving specific points. Okay, and again, look at my final graph. Right? There's nothing that's below there now. Okay, reciprocals. So the word reciprocal, what does it mean? If I write it on the test, this is what I would be doing. This means reciprocal. 1 over something, flipping, reciprocating. Do you remember, well, I don't think I used this word with you, invariant. There was a specific point that stayed put on a reciprocal graph. Whatever makes something stay on a reciprocal? When you flip some kind of number, it doesn't change. What number in math doesn't move? No. 0 changes. Because 0 becomes 1 over 0, which is different. Yep, 1. Remember, we're dealing with the heights. There's also something else though too that didn't change ever. What was some other number that doesn't change? -1. Okay, there was a 3-step process here. So the first step was heights of 0. That's kind of where I actually started from. Because the reciprocal of it is 1 over 0, which is special. Anybody remember there's a fancy word? Undefined. And how do you graph the number undefined?
Dash.
A dash line. There's a. It starts with an A. What did you say?
Something whack.
Amplified.
Asymptote.
Oh.
It's an asymptote. Don't worry, you'll know that by grade 12. Asymptote. That's how you graph undefined. So, where do you see ever a height of 0? At 4. So now the new height is undefined. At -2. Now the height is undefined. So that was always my step 1. My step 2 is that invariant part. So wherever there's a height of 1, wherever there's a height of -1, those points will not move. So there's 4 coordinates here. Those 4 coordinates will never ever change. And then the last step is to do the pattern. So remember, a big number, when you reciprocate it, would become small. For example, 100 is big, it would become 1 over 100, which is really small. Okay, so we're going to have to do chunks. So I'm going to do this chunk first. So the graph is fraction numbers. From here to here, these are fraction numbers. Can I just call them all small numbers? So what will these turn into if they're really small? Big. Okay, and they're negative. So if they're small negative, you now need to turn them into big negatives. So you would do that. Okay, or you can think about it like this. These are getting closer to 0, so now they're getting farther from 0. Whatever you like to think about it. Okay, let's do the middle chunk next. This triangle part had a top height of 3. So if this was the highest, it's actually now going to turn into the lowest. What's its lowest height going to be now? How do you change the height of 3? 1/3. So that was the top. Now it's actually the bottom. What do you think is going to happen if you're connecting that point and that point and that point together? Does it also follow, right? Like this little section was small, so now it's big. Small section, big section. Okay, and then the last section. So if I put my pen in this zone, what's going to happen to these when you reciprocate this? It's going to go down. Okay, this is close to 0, so now I'm far from 0. Then, what's going to happen here? If this is going away, away, away from 0, what's it now going to do? closer, 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 closer to 0. And this has an arrow on it now. So, because this one thing here, it actually causes us to do one more thing on this graph. What happens in math if there's a pattern that goes closer and closer and closer to something and never ever touches it? It is now a asymptote. Okay, only because of this arrow to say it's going to keep going, 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 going closer. Okay, this one didn't cause us to write an asymptote there because it stopped. Okay, this is a quadratic inequality. So I need you to factor and figure out where it equals 0 first. So simple trinomial. Should have given you a harder question. This one's too easy. Okay, did you write a -8 and a 4? Okay, now I'm going to do a number line. And I'm going to put a -4 on there and a +8. So we're basically doing, if x is this, then y is, that's kind of what we're thinking about. So if x is that, what's happening to y? So I can already write, if x is -4, y is exactly 0 at those spots. Okay, now I want to know in these zones, what's happening in the zones. So let's do a test. So what x number could we try there for a test? -5. Again, you could plug -5 into your original and see what it comes out to be. For me, it's faster just to go -5 subtract 8 is a negative value. And -5 plus 4 is a negative value. So I know that number will end up being a positive number. Okay, again, you could have done -5 squared minus 4 times -5 minus 32. I'm going to test something in that zone. And 0. 0 is in that zone, so for sure I'm going to use it because, boom. What's your function when you're at 0? Really fast. This fast is how you should find it. If you put a 0 in, what is it? -32. Negative. Right? Remember that? When you put 0 in, boom, -32. And I'm going to go with a 10. So 10 minus 8 is positive. 10 plus 4 is positive. So we have to answer the question. Here's what the question says. Where did we end up bigger than 0, greater than 0?
In the middle.
So bigger than 0, are you positive or negative if you're bigger? Positive. Positive. So these are the places I can be. Can I be on there or not on there? Am I allowed to go on to -4 or not? Not. So I can't be on those. So how do I write it? as a domain. How do you say this as a domain? Negative infinity up to -4 with a soft bracket, yeah. Okay. And then this domain is from 8 to infinity. So on your test, pay attention. If this says that you can be equal to it, then you're getting to be a square bracket because now you can be on those places. And also on your test, I think I amped it up a notch by doing a cubic. So if you ever end up with probably some kind of factoring like this, do you remember that where you GCF and simple trinomial factor all in one question? Remember that kind of question? And you're going to have actually 4 testing zones, okay? Okay, solve the system of equations and then graph. Okay, if I allowed you to choose a method, what would you pick? Elimination or substitution? If I said you could pick substitution, yeah. I'm going to put this in place of the y. That's a substitution, right? So that's what it would look like if I did a replacement, a substitution. How do you ever go about solving an equation that looks like this? Equals 0. Okay, so I'm going to be going x squared's the boss, so it's going to stay. So we're going to go everything that way. So x squared everyone's good with the move? They got the correct quadratic? Okay, let's factor. Not too many choices here. What multiplies to 3? Okay, on the test, I get this quite often. People think that they're done. Then they only get a 2 out of 3 on this question. Why am I not done? What do I still need to do? Besides that, I still need to do something else.
Y-intercept.
I need the matching y value. I need to plug it in yet. Okay? So it's not the y-intercept, it's just the matching y value to that. Okay, it doesn't matter where you plug it in. You can go to this equation, you can go to this equation. Doesn't matter, you just pick which one you like better. So plug in a 3. See what you get out when you plug a 3 in. This one or that one, it doesn't matter. I'm getting a 7. Okay, same thing, plug a -1 in there. And what did you get? -1. Okay, what if I forced you to show me elimination? I said you have to solve this by eliminating. That's another method. I wouldn't choose elimination. I would have definitely picked substitution on this one, but on your test there might be one that's substitution, one that's elimination. What is wrong with eliminating right now? What happens when you eliminate things? How should you set it up? You kind of have to have your stacked columns, right? Okay, so I'm going to kind of make a column for y, which is good. There's going to be a column for x squareds, there's going to be a column for x's, and there's going to be a column for numbers. And you know what I'm actually going to do where I don't see stuff? I'm going to write 0. Just to show you that I didn't have anything in that column. Okay, what variable do you want to get rid of? There's actually only one option here. Which?
Y?
The y's. How would you get rid of the y's? Would you put them together with adding or subtracting? So subtracting. So y subtract y, 0. X squared subtract nothing is just an x squared. 0 x's subtract 2 x's. Negative 2 subtract 1. Okay, we're not going to go anymore because look at that. We got to the same spot here. Just as a different method. Okay, we are going to graph this. So what do we know about this function? What's the shape of it? Parabola. It's an upward parabola with a -2 y-intercept. So can you start me at -2 and do your 1, 1? 2, 4? Go another one, go 3, 9. Okay, y equals 2x plus 1. What shape is that? It's just got an x. It's not an x squared. So what's the x shape? A line? So I'm going to think of mx plus b. What's the m? What's the b? So 1 is where I'm going to start. That is my y-intercept. And then 2 is the m, the slope. So 2 is the rise over the run of 1. So up 2, right 1, up 2, right 1. Why did I start at -1? Is a good question. I was like, my thing's not matching. Thank you. Thanks, Regan, because I was like, why is my thing not crossing where it's supposed to? There we go. Did it check out? Did it meet where we wanted it to? What coordinate here did it intersect? What coordinate did it intersect at?
3, 7.
3, 7. Look at that. How good we are. -1, -1. Okay. Okay, graphing a system of inequalities. So I need to do some work here. I need to get it into y alone. Y equals mx plus b. So we're going to leave the 3y alone. Greater than or less than, or greater than or equal to. Move the x. Move the x. So this would be negative 2x. Keep the negative 9 where it is. So do you see what I did? All I did was moved that into that position. Okay. Now I'm going to give candy to all the kids. I'm going to divide by 3, but everything gets it. Y is greater than or equal to negative 2/3 x, just leave, minus 3. Okay, let's graph that. So negative 3 intercept. You can go down 2, right 3. Before I draw the line, you also have to think, is it going to be a solid or a dashed line?
Solid.
Solid, because you can be on it. It says you can be equal to it. Okay, which side of this would be the greater side is your next question. So you would have 2 options to be on it. What do you think is the greater, my pen or my highlighter? The pen side is greater. So I'm just going to put some arrows to remind myself like that. Okay, so the next equation, we're going to have to revamp it too. Okay, so negative 3y is going to stay. I'm going to be moving the x term, and I'm going to keep the number term. Mx plus b is what I'm getting. So y is needing to get a lone here, so we're going to divide. But something crazy happens now. What are we remembering? The sign has to flip because my algebra was that I divided by a negative. So the sign flips around. If you're okay, I'm actually going to change that to a positive 2/3, right? Positive 1.
So that's when you divide by a negative.
If you're dividing or timesing, but we won't ever be timesing, but if you divide by a negative, the sign flips around. So oh, I did it again. What am I doing today? Apparently I don't know where positive 1 is. Positive 1, I need to go up to right 3. Solid or dashed line when you draw it?
Solid.
Solid again. Okay, you have 2 options. What do you think? Less than. Which one looks less? Pen or highlighter side is the less than side. The pen side again. So down. So that side of it. Okay, the third line, we have a third line here. This is a special line because you don't have y's and x's. It makes it special. The two special lines are the ones that are either vertical, straight up and down, or horizontal, flat. Which one is this one with just the x?
Vertical.
Vertical at 7. So you're going to go to 7 and draw vertical. Is it solid or dashed when you're drawing?
Dash.
Vertical dashed line. And you have to be less than it, so then you're either thinking the pen side or the highlighter side here. So less than it would be going this way. So then the region that's working for all three arrows ended up being that triangle in the middle. Okay, this is the last question. A system of equations, three variables. Okay, before we begin, we're going to map out a plan. Which letter are we going to commit ourselves to getting rid of twice? Does any letter specifically look easier than the other one?
Y.
Y? Okay. Eliminate Y, eliminate Y. Okay, you have to do it twice. Commit to one letter, then you're going to be doing it twice. So are you good with me picking 1 and 2 on that? So I'm going to put 1 and 2 together, and I'm going to get rid of Y. Okay, so all I did was copy them down. And you always will ask yourself, should I add or subtract? To get rid of the y's. Add. Okay, go slow and steady. There's always small errors in this if you're rushing. So -2 plus 3 is 1x. Gone. 1z plus 1z. 14 plus a -5 is 9, right? Okay, we're also going to put a label on this. Let's call it the fourth equation now. Okay, what do you want to put together now? We got to have a different combo. 1 and 3, 2 and 3. Which one do you want to do? 1 and 3. Okay, are you understanding that you would have to multiply by 2? Does that make sense? The third line would have to get doubled so that it's set up. So here you can see my organizing. I'm going to multiply that one by 2. Go back, when you're done that, go back and say, did I? Because I get this so often. They multiply, but then they forget to multiply this side by 2 or something. Make sure you put your pen through it again, say, did I do it to everything? Okay, we have to attack the y's because that's what we're committed to doing. So add or subtract. Subtract. What is a negative 2x subtract a negative 2x? 0. It's actually gone, and then that's gone. Well, that's nice. This makes 5z. And this makes 30. We're going to call this the fifth equation. So, we got like a bonus here. We actually got rid of 2 letters here, which helped us. But normally at this point, I would put equation 4 and 5 together somehow. But we can actually just solve for z right here. So z equals 6. Now, remember my...
What happens if you would have combined it?
You could have like times this by 5 and times this by 2 and then set up the z's with each other.
Oh,
Yeah, you could do that kind of thing.
So you would have got the same answer.
Well, then I actually would have got something for x right away.
Oh.
Yeah. Because I would have got rid of my z's on that one.
Oh, yeah.
Yeah. Okay. What do you do once you have a variable? What do you do plugins? Where's your first plugin? Which numbered equation should you go to? 4 or 5, that middle level. Okay, your plugins happen in the middle first. So I'm going to go to actually equation 4. X plus 2 plug in Z. I officially have 2 of the letters. So I still am doing plugins. Where do you go when you have 2 of the letters? Where's your plugin now? In any of the first 3. You look and you pick. Doesn't matter. First, second, or third equation. Doesn't matter. You pick whatever one might look easier or whatever.